Hello and welcome back to the Cognitive Whiteboard. My name is Dan O'Mara and I'm here to talk to you about a way to evaluate your 3D saturation models. And along the way, this plot that I show you will stimulate a lot of discussion with your interdisciplinary asset teams. So I've been in the industry for quite some time, and I was actually there at the dawn of geomodeling. And when we started to put together geomodels, we had some simple expectations. One was that our models were going to honor our observations, and the main observations were the well data, the well logs. Another was that our models should honor the physics. So when it comes to porosity, there is no physics. So people tend to use just geostats for porosity. But when it comes to saturation, we know there's physics to be honored, and that's the physics of capillarity. We have plenty of data in the laboratory, and that's why we get capillary pressure curves. So the physics becomes very important when it comes to saturations. And the physics tells us that as you go up in a reservoir, it's not just an easy thing where the oil saturation uniformly increases, but the oil saturation is going to depend upon the heterogeneity in both the porosity and the permeability. They're all connected. Okay, so if you put together models that are just driven by the physics, then what we're going to do here is we're going to evaluate those models. And what I found is I put together this kind of a plot to try and evaluate them. And here's how this plot goes. So we're looking at 3D models, and we're only going to consider cells that are penetrated by wells, because the wells are where we have observations. So along the x-axis here, we're going to plot the properly pore volume weighted saturation log, the water saturation log. And on this axis, the y-axis, we're going to plot the water saturation that's sitting out there in the 3D model. And all we're going to do is look and see how we're doing, how they compare. You would expect to get a 45-degree line, at least I did, with all of the data generally being on the 45-degree line, because after all, if you honor the physics, you should be honoring, the observations. But what I found was kind of strange. And one of the things that just jumped out right away is you see data up here along the top. And what that's saying is that the water saturation that's coming out of the model is 100%, but yet there's well data that's contradicting it, saying we have as much as 80, 90% oil. So what could possibly be going on? So I turned back to the geological models here and realized, hey, there are faults in those models. And with the faults comes the possibility of compartmentalization. And so, for instance, in this model here, we've got 4 free water levels. And you start to realize that this kind of a data is a signature for compartmentalization. If you look at this plot more, and you'll see that I was not seeing nice straight lines, even when I discounted for this. And if you're in this area here, the water saturation in 3D is higher than the water saturation in the wells. So here you're underestimating the reserves, and conversely, you're overestimating reserves in this part of the plot. So in going around the industry, over the last 20 years or so, I would see people who were struggling with, they had computer programs here that basically said, hey, I can do the physics, but when it came to observations, when we put together these kind of plots here, we were repeatedly seeing things like this, where we had lots of scatter here, and then we had what seemed to be evidence of multiple compartmentalization there. So what I did is to come up with a methodology that both honors the physics, which is the first thing that people were doing, but also honors the observations, so that every time that we put together a model in 3D, for saturation, we get plots like this, which is what you'd expect from, porosity. You should honor the observations, and you should honor the physics, because after all, that's what Mother Nature does. If you want to learn more about how to get there, then Luke will provide you with links to our website below. And so that's all from the Cognitive Whiteboard today. See you again next time.